If you like our content, please like, subscribe, and click the notification bell to get alerts when we introduce new videos.
So in this module, we're going to build on what we've just learned with regards to iBeacon, and we're going to do a similar thing now, but instead of using an iBeacon BLE tag, we're going to use Eddystone devices. So the two technologies are very similar. They have a different payload and a different vendor ID structure, but from an application, an IoT controller, and from an access point perspective, the plug-in operation and configuration is basically the same. So if we look at the network configuration, it's exactly the same as we did with iBeacon. We have our devices, our Eddystone devices or beacons down here on the edge that are mobile, moving around, providing information and telemetry data up to the IoT access points, IoT enabled access points, through our IoT network and then into our IoT controller. And instead of using the iBeacon plugin, we're now going to use the Eddystone plugin to forward that data to detect what's going on and then forward that information out to our third-party management application. And again, we're going to use our rules engine to do that. So again, here we are at our IoT controller dashboard, and you can see we have no plugins enabled for BLE at this particular case. So the access points are now disabled, and we can see we have 0 beacons visible by our IoT controller and by our access point. And as we look at the access point specifically, you can see that there are no plugins or enabled services within the BLE radio. So very much like we did with the iBeacon, now we can set up the Eddystone connection into our application. So we come to our admin, we go to plugins, and again this time we're going to select our Eddystone plugin, and we're going to activate the Eddystone plugin. As before, we have our aggregation setting, and again we want to make sure that we globally enable connectors on all valid access points. So we've now enabled the Eddystone plugin on any BLE enabled AP within the network. We need our key that we did before, so again it may be optional, may not be, depending on your specific service and application. We need to have the IP address of the server that we're going to be forwarding the data to. So again, 192.168.111.120 is our destination URL, and the port, again we're going to forward this to our Node-RED rules engine, and again we need to define the endpoint that we're going to push the data using an HTTP push request. So we're going to use /IoT Eddystone as the destination URL, and again we can add filtering if we need to in this particular case. So that's everything we need to configure, so we'll hit apply on that, and the IoT controller will now start that Eddystone forwarding service. It will then reach out to every single access point and IoT gateway on the network, and it will enable the Eddystone plugin on each of those access points. So now that our Eddystone plugin has been activated, we can now go and check that everything is running correctly within our network. So we can see that the IoT APs, and if we select our BLE enabled access point and we scroll down, you can see that this has now been enabled for Eddystone. So you can see the Eddystone plugin has been checked, and that's been done automatically by the IoT controller because we've told it we want to support that. Then on top of that, we can go into our dashboard, and again we can see the IoT controller is reporting that the Eddystone plugin is enabled, that there are 2 beacons currently visible by the access point, and that everything is correctly reporting. And again, as before, we can now go into our IoT devices and our beacons, select our beacon, and we can see that the access point is now able to see the beacons from the different vendors, but now using the Eddystone format rather than the iBeacon format. So that basically completes everything we need to do to set up on the IoT controller. Now we can go and take a look at the rules engine. So as we open our rules engine now and we have our blank flow, we need to do the same functionality that we did in the iBeacon example. So we're at our rules engine on the URL that we are forwarding the Eddystone data to, and we are at port 1880. So again, just as before, we're going to set up basically the same capability. So we're going to have an HTTP in, we're going to provide a HTTP response, and we're going to also have a debug node in there. So we need to go in and configure each of these as we did before and provide the end URL, the post confirmation. We need to provide the response back to the IoT controller, and we need to have a debug node. And again, we'll look at the entire message. Okay, once we've done all of that, we can now deploy that node and we are good to go. So immediately we're seeing the data coming in from the IoT controller. So these are now packets that are being pushed by the IoT controller. Now these are just the same as we had with the Eddystone data, but these are now as iBeacon data, but now these are with Eddystone. So again, we can open the payload. We get the same information as before, so we get the IP address of the access point, its serial number. We also get the firmware version, the latitude, longitude, AP location, and its AP name, timestamp of the packet, its altitude. And then again, as we break down and we go into the events list, you can see we've got 2 events listed, and we have each of the beacons data displayed. So we get the device EUID, and then we get the data information along with the timestamp and the RSSI of that device. So very much in exactly the same way we were able to do with iBeacons, we're now able to detect and forward Eddystone data. Now the nice thing is we can forward this data into multiple locations. So we could have different flows dealing with Eddystone data or iBeacon data, or doing some pre-processing of that data before we actually then do any location-based services analysis. But because we have all this data now, we're able to now export this and use it within a much larger system for maybe a location-based services or for panic buttons or asset tracking.